Find dy dx given that y equals 1 integral 1 to cosine of x of t squared over quantity t plus 1. Okay, so this is a fundamental theorem of calculus problem. And the way I start these, to give away that it's a fundamental theorem of calculus problem, is you have you're trying to find dy dx, and your x is here in integral, and then you have some other variable, often referred to as a dummy variable, in your equation. So the way I approach these, yeah, I'll stick with blue. I like blue. Everyone likes blue. We'll say that this is g of x right here, little g of x. Therefore, we could say that y is big G, the integral of little g of x, evaluated at cosine of x minus big G of 1. And this is essentially, this step right here is the fundamental theorem of calculus. So then from here we want to find dy dx, so we'll take the derivative of both. Dy dx equals, so we'll have little g of cosine of x times cosine of x, the derivative of cosine of x, minus the derivative of g of 1. Boop. And simplifying things a little bit, so g of 1 is just going to be constant. And so when you take the derivative of constant, you're just going to get 0. So then we will be left with, and I'll write this one more time, well, 2 more times, g prime of cosine of x times the derivative of cosine of x, and the derivative of cosine of x is negative sine of x. The derivative of positive sine of x is positive cosine of x, but when you go the other direction from derivative of cosine to sine, you have a sign switch. So let's see here. Now we need to plug into g prime of x, this part right there, and so this will be cosine squared of x over cosine of x plus 1 negative times sine of x. Yeah, that looks pretty good. And so then looking at our possible answers, so we got, this one looks correct, except there's supposed to be a negative sign involved. And for this, I think there's actually just the answer probably wrong, because it's so close, and I'm pretty darn confident about my answer. So here, it's supposed to be, pretty sure it's supposed to be negative. Cosine squared of x over cosine of x plus 1 times sine of x. So to look back at what we did here, the way I approach these kind of problems, fundamental theorem of calculus problems, is you're given an equation and you want to find the derivative of it. Sometimes instead of being given y and trying to find dy dx, you'll be given big F of x and asked to find f of x. Same idea, same process. So the idea for this is you start with an integral and you're going to go for the normal function. For what we did here, we started with the normal function, y of x, and we're trying to find dy dx. So the way I do it is I say, all right, the function that they give you, call that g of x. The fundamental theorem of calculus says that when you take the integral, it's going to be the integral of g of x evaluated at each of the limits of integration. Often one of the limits of integration will be a constant, so it'll disappear, but doesn't need to. And then when you take the derivative of the limits of integration of big G of x evaluated at the limits of integration, you'll use the chain rule. If it was just x and not cosine of x, then that chain rule would just come out to 1 and you could effectively ignore it. You'd effectively just plug x back into the equation. But what you need to do the chain rule here, so that's why we had this cosine of x, and it goes to negative sine of x. You get that extra multiple in there. Plug things in, work through the problem, and then we get an answer. Ideally, it matches up with the answer we're supposed to get. In this case, no, but I'm confident. So that is how I would approach this problem. Appreciate you stopping by. I will see you on the next one.